Okay, the next few videos will I will discuss Numpy, which is the very popular package for numerical Python. Actually, Numpy is like list, but it is much faster than list. One restriction, if we restrict a list, remember a list actually is a collection of a lot of data objects that was so abstract as we saw in previous videos. If, for example, we restrict a list that all the objects, they must have same type, all the elements in the list, for example, they have same type, then that list with all the same type, that is what the Numpy looks like. But Numpy is way more faster, and the reason is, even if you define a list with all the elements that are, let's say, of same type, but because list in abstract way can handle heterogeneous kind of objects, the functions that we will apply on these items, they will no longer be faster. Further, to store each element, we have to store the information or metadata for that element. In Numpy, it is both. I mean, it is efficient with respect to memory, because if the type is same, we need not to save information about each element, because we need just to save the information about the type, because the type is same for all elements. Further, when the type is same, we can write functions that are much more faster than list. So Numpy is very popular. It has very fast universal functions available, the methods that are available in Numpy, and it's a package. I mean, it's a whole directory structure containing a lot of packages inside, a lot of modules, and so much. At the end of the day, it's simply, or in layman terms, it is like a list with all the same type objects, and it is much more useful when all these objects are numeric type. Although you can have a Numpy array with string data types, I mean all the strings or all general objects as well, but the power of Numpy array will become much more evident when we will be working on numeric type data. So in this particular course, we will focus more on numeric data than other kind of data. So that's how you write import. Numpy is installed, or if you have installed Python using Anaconda, Numpy is already installed there. It is in the site packages, kind of a built-in package. So import Numpy, we can stay as it is, but we can rename this Numpy just NP, that's most popular name. We can write any other name, but if you see the books or internet or somewhere, this NP somehow becomes much more popular. Okay, now we can define an array, for example, np.array. That's array is just a method of np, kind of function. And we can define an array using list. This is the list of several numbers. Or we can define array as a tuple as well. So whether we give a tuple, whether we give a list, an array is defined, and then we can see the contents of this array, this np array. So let's just go to our friend Jupyter Notebook and get our hand well gripped on this Numpy. So first of all, we need to import Numpy package, and we may rename as, for future use, as np. So let's say that is imported. So now let's say a is an array. Let's say np.array. That's a function, and we may have a list inside. Let's say 1 2 3 5 7. Let's say that's array. We can also define the array using a tuple rather than a list. It's our choice which way we define the array. Either way, 2 3 5. Let's say that's another array, for example. So if we print, for example, a, it will give us a, but if we just see the type of a, it will no longer be a list. It will be an nd array, numpy.nd array. That's an n-dimensional array. Okay, great. So there are so many attributes of this A and this B. Similarly, if we see the type of B, although we have defined this B using a tuple, but the type is the same. It's a Numpy object rather than a list or a tuple. So that's how you can create the array. One more thing that is important is to check the attributes of A. For example, a dot d type, that will tell us the data type in A. So for example, A stores all the data that is integer 32. At define time, for example, we can specify the data type if we want. We can specify d type if we want. For example, integer. That means A is integer. Here we can define, for example, d type as float, for example. So data type becomes float. There are several other options that are available to define the data type. But even if we don't define, the data type can be defined automatically based on contents. That's what the dynamic typing means. So if we now define type, that's this. If we now check the type of A, that is again integer 32. But if we check the type of B, D type, that might be a float number. Yes, that's float 32. Again, there are 64-bit support as well. I mean, we can define here. There are several options here available. So that's how we can define the NumPy array. That's just getting started with NumPy array. In the next video, we will play with these arrays a bit more. So hope to see you in the next video.